Alright, so this is the Chemistry Section 16.2 Lesson Video Part 1. Now this section's not really that difficult or long, but I put so many examples of the math in my PowerPoint that I'm splitting it up into 2 videos just so that it's not so incredibly long. So if you kind of understand how to do some of the math, you can always kind of skip ahead so that way you're not stuck watching me do the same thing over and over again. But some people need to see the same thing over and over again, so it's there for those of you who need it. Alright, so we're going to talk a little bit about concentrations of solutions. So the concentration of a solution is the measure of the amount of solute that is dissolved in a given amount of solvent. So if I have 100 milliliters of water and I put 50 grams of salt in there, then my concentration is that I have 50 grams of salt in that 100 milliliters of water. Well, there's some different units and ways that we can express concentration, and so that's what we're going to learn in this section. A dilute solution is one that contains a small amount of solute. A concentrated solution is one that contains a large amount of solute. So in my pictures down here, we have water, and we start adding a blue chemical, maybe it's copper 2 sulfate. So as it starts building up in the water starts turning more blue. And then as we add even more, it gets even darker blue. So this would be the more dilute, and this would be the more concentrated. Now, not every substance changes the color of something as you add it. So for example, if you add salt or sugar to water, it's not going to start, changing color. So what unit are we going to use for concentration? Well, one of the units we use is molarity. It is represented by a capital M. It must be capital. If you put lowercase, that's meters, and I count half off for incorrect or missing units. So molarity is the number of moles of solute dissolved in 1 liter of solution. So our formula is molarity equals moles of solute per liters of solution. And so I always write it like this. Molarity is moles per liter. So in other words, you have to have moles of solute. You can't have grams. You have to have liters of solution. You can't have milliliters. So you got to make sure your units are correct before you plug into this. So first sample question. Intravenous or IV saline solutions are often administered to patients in the hospital. One saline solution contains 0.90 grams of sodium chloride and exactly 100 milliliters of solution. What is the molarity of the solution? Okay, so we know we're looking for molarity. So I know molarity equals moles per liter. The problem is, though, they gave me grams and they gave me milliliters. So I have to correct those units or convert them before I can plug in. So I'm going to start with my grams first. So hopefully you remember molar mass. Okay, we've only done it a million times at this point. So I start with what I know. So I know I have 0.9 grams of sodium chloride, NaCl. So remember, the way we get between grams and moles is using molar mass. For molar mass, we just find the elements on the periodic table and add up the masses. So Na is 23, Cl is about 35. I always round to whole numbers. And so that gives me 58 grams in 1 mole. So I follow the golden rule. My grams go on bottom, so it will cancel. So my 58 grams goes on bottom. And remember, whenever you add up molar mass, that always equals 1 mole. Okay, so then, because one number is on top and one's on bottom, I'm going to do 0.9 divided by 58. And so when I do that, I get 0.016 moles. So now I know how many moles of salt I used. Then it says are in exactly 100 milliliters of solution. Alright, so hopefully you already know that 1 liter equals 1,000 milliliters. If you don't have that committed to memory, you're not required to, but it just makes your life a lot easier if you know that. Okay, so they gave me 100 milliliters. I know 1,000 equals 1 liter. So all you have to do to convert from milliliters to liters is take your milliliters and divide by 1,000. Or some of you just like to take and move your decimal 3 places to the left. Either one is fine, but this ends up being 0.1 liters. All right, so now we have liters and now we have moles, so now we can plug into our formula. So I put my 0.016 moles on bottom, and I put my 0.1 liters. I'm sorry, I said on bottom, but I wrote on top. I put 0.016 moles on top and my 0.1 liters on bottom. And so then once I divide, I get 0.16. And so a mole and a liter will not cancel. So you have two options for what to put as your unit. You can either put moles per liter, or what I prefer is to put your capital M for molarity. That's what you'll see me use in class, is the capital M for molarity. But if you left it as moles per liter, that is also okay. All right, now, you aren't always going to have to convert. You just need to check your units to make sure. If it gives you moles and it gives you liters, you just go ahead and divide and move on. All right, so let's look at a lot of different examples just so you can see any little trick that might happen. That's why the videos will be so long, is because I just have so many examples. All right, so it says a solution has a volume of 2 liters. So liters is a good unit. I can use that. And contains 36 grams of glucose. Grams is going to be an issue because what do I need? I need moles. What is the molarity? So I'm looking for molarity. All right, so they gave me liters like I want, but they gave me grams and I need moles because remember, molarity equals moles per liter. All right, so I'm going to take my grams, which is 36, and it says of glucose, and if you don't remember what glucose is from biology, it's C6H12O6. All right, and so remember, to get from grams to moles, I just need to use molar mass. So I look at the periodic table, C is 12, and I multiply that by 6. H is 1 times 12, and O is 16 times 6. Once you do all that, you should get 180 grams. Now, follow my golden rule, and I'll put my grams on bottom. So I'll put my 180 grams on bottom, and remember, molar mass always equals 1 mole. So I do 36 divided by 180 because the 36 is on top and the 180 is on bottom, and so I get 0.2 moles. So once I know my moles, I can plug moles in, and they gave me my liters, so I can put liters in. So now I'm ready to solve. So I say, okay, 0.2 moles divided by 2 liters. And so once I divide that, I get 0.1 molarity. All right, and you can put the unit afterwards, the substance afterwards. You have to put the unit. You can put the substance afterwards. I'm not super picky about that just because we won't be changing substances in this chapter. But you can put the substance afterwards too. So I want you to pause the video and you try this bottom one. Remember, make sure you have moles and liters before you plug into your formula. All right, so I'm going to assume you paused it, tried it, and already got it right. So let's look at it together. So it says a solution contains a volume of 250 milliliters. So this unit is going to be an issue because I need to have liters. And contains 0.7 moles of NaCl. Moles is perfect. I need moles. What is its molarity? All right, so again, we're looking for molarity. And so we know molarity equals moles per liter. So I have moles, but I don't have liters. I have milliliters. So remember what I told you to do. You can either divide it by 1,000 or take your decimal and move it 3 places to the left. So this becomes 0.25 liters. And once you have that, you can plug in. So my moles is 0.7 moles, and my liters is 0.25 liters. Okay, so I do 0.7 divided by 0.25, and I get 2.8. And then, of course, my unit is moles per liter or molarity, and that is NaCl. So this would be a 2.8 molar solution of NaCl. All right, so hopefully you got that one right. Now, sometimes, though, you may be asked a question that involves the molarity formula, but you might not be solving for molarity. So I want to make sure you know how to rearrange the formula and solve for other variables also. So see, this is one of the reasons why there's just so many examples. I just want to make sure you know how to do it any possible way I might ask. All right, so let's look at the first one together. So it says, a household laundry bleach is a dilute aqueous solution of sodium hypochlorite. How many moles? So see, this time we're looking for moles. We're not looking for molarity. How many moles of solute are present in 1.5 liters, so there's my liters, of 0.7 molar NaClO. So if you notice, they gave me the correct units. I have liters in molarity, and I'm looking for moles. So in other words, the only thing I need to do is just rearrange my formula. Okay, so our formula says molarity is moles of solute over liters of solution. Well, I'm trying to solve for moles. That means I need moles to be alone. So to get liters to the other side, I do the opposite. So right now it's being divided. So I multiply both sides by liters. So see, then they cancel out on this side. So moles equals liters times molarity. And then they gave me liters and they gave me molarity, so I just plug in. So 1.5 liters times 0.7 molarity. So once you multiply that, you're going to get 1.05. But what unit are you going to get? What's a liters times a molarity end up being? Well, remember, molarity is moles per liter. So if you know it's moles per liter, you can see that the liters would cancel because this one's in the numerator and this one's in the denominator. And so then what you're left with is moles. All right, so that's how your units cancel. So when you're canceling units, you can change molarity to moles per liter, and that'll help you cancel those units. All right, so let's look at a couple more like this where you have to rearrange. And sometimes you may need to convert, okay? In this example, they gave me all the correct units, but sometimes they won't. So remember, when you're using this formula, you have to have molarity, moles, and liters. All right, so let's look at the top one together. So it says how many moles, so again, I'm looking for moles, of ammonium nitrate are in 335 milliliters of 0.425 molarity ammonium nitrate. All right, so I'm looking for moles, which is fine. They gave me molarity, which is fine, but they gave me milliliters here. Remember, when I'm using this formula, I have to have liters. So you can either take this number and divide by 1,000 or move your decimal 3 places to the left. So it becomes 0.335 liters. Once I have this in liters, I'm ready to plug in. Okay, so remember, molarity is moles per liter, but I'm solving for moles this time. So to get liters on the other side, I multiply both sides by liters. So moles equals liters times molarity. And then I'm ready to plug in. So I got my liters, 0.335 liters. I got my molarity, 0.425 molarity. Remember, molarity is moles per liter. So you can see that liters cancel and I have moles, which is what I want in my answer. And so then I just multiply the two numbers. And so once you multiply those two numbers, you get 0.142 moles of ammonium nitrate. And that's all you do for these, okay? Is sometimes you just may need to rearrange the formula. All right, so I want you to pause and try the bottom one, but before you try it real quick, I just want to point out something. It says how many grams. Well, we can't solve for grams with this formula, but remember, using molar mass, we can always convert between grams and moles. So what you're actually going to do is solve for moles and then convert it to grams using molar mass. All right, so pause it, try this one, and then we'll look at it together. All right, so it says how many grams. So remember, I'm going to solve for moles and then change it to grams. Are in 250 milliliters. So remember, milliliters is not an acceptable unit to use for this formula. So I just divide it by 1,000 or move my decimal 3 places and I get 0.25 liters of 2 molar CaCl2. So my molarity is 5. So let's go ahead and start. So we have molarity is moles per liter. Again, I'm solving for moles this time. So I multiply both sides by liters so that it cancels. So moles equals liters times molarity. And so then I just plug in. So I changed my 250 milliliters to 0.25 liters, and I multiply by my molarity, which is 2. And remember, molarity is just moles per liter, so you can see those liters cancel. So once I do that, I end up getting 0.5 moles of calcium chloride. But the problem is they didn't ask me for moles, they asked me for grams. So now I need to use my molar mass to get to grams. So I start with what I know, and that's 0.5 moles of CaCl2. I add up my molar mass off the periodic table, so Ca is 40, Cl is about 35 times 2. And so once I add all that up, I end up getting 110 grams. So I'll follow my golden rule. Since moles is on top, I put mole on bottom. And molar mass always equals 1 mole. So 1 mole on bottom. And then 110 grams on top, because that's what I added up off the periodic table. Since both my numbers are on top, I'm going to multiply. I'm going to do 0.5 times 110, and I'm going to get 55 grams of calcium chloride. And that's all you have to do. Okay, so hopefully you got that one right. A lot of times if I ask for grams, that's what throws people off. They don't even know where to start. A lot of times you can't even figure out which formula to use because you're trying to find something that has grams in it. Just remember, if you're using a formula and I ask for grams, you can always solve for moles first, just like we did in the ideal gas law equation. Alright, so let's move on to our next formula. So we have this one, molarity equals moles per liter. And so our next one is going to be dilution. So dilutions, diluting a solution reduces the number of moles of solute per volume, but it does not change the total number of moles of solute in solution. For dilution, more solvent is added. And so its formula is M1V1. Hopefully if you were good with the gas laws, this looks a little similar to Boyle's law, but instead of pressures, we have molarities. M1 times V1 equals M2 times V2. And so of course the 1s are our initial concentration and volume, and our 2s are our final concentration and volume. And the capital M, of course, is molarity. Volume in this formula is called volume. It's not called liters. So it can actually be in any unit, as long as if I give you 2 volumes, they're the same unit. All right, so let's talk about dilution real quick. So let's say that you bought some of that Mio. You know how you squeeze it in and you can squeeze as much or as little as you want. And let's say you have a glass of water and you think you need a whole lot. So you squeeze a bunch in there. And then you taste it and it's way too strong. What do you do to fix it? You can't pull the Mio out. So what do? Well, pour the glass of water into a bigger container, add more water to dilute it. So let's pretend like then it looks like this. All right, so you taste it, it's still too strong. What can you do? You can't take the Mio out, so you pour it in a bigger container and add some more water. And so if you notice, the color is getting lighter each time you do that. Now, is the same amount of Mio in there? Well, in this picture it can't be, because of course you would need a bigger container to hold the extra water. But if you were putting it in a bigger container, there's the same amount of the Mio in there. What's changing is the amount of water. So the solvent is changing, not the solute. All right, and that's a common mistake, is I'll say, you know, what happens to the solute after a dilution? And everybody wants to say that it's less or it decreases. And it doesn't. It stays the same. What changes is the amount of solvent increases in a dilution. All right, so let's look at how to use this formula. So it says how many milliliters. So milliliters is a volume. So I'm going to put V1 question mark, just like gas laws, of aqueous 2 molar magnesium sulfate. So there is my first molarity, so my M1. Solution must be diluted with water to prepare. So see, we're making this part. So some of you have trouble figuring out where the 1s and the 2s are. In some of these questions, you just really have to read. Once it says you're preparing something, what you prepare is the 2. Like those are the second or the final amounts. All right, so to prepare 100 milliliters, so there's my second volume, of aqueous 0.4 molar magnesium sulfate. And so there's my second molarity. All right, so milliliters, like I said, is fine to use in this formula, not in the top one. All right, so we have M1 V1 equals M2 V2. And so we are solving for V1, so I have to get it by itself by dividing both sides by M1. So V1 equals M2 times V2 over M1. Oh my gosh, I love just rearranging and plugging into formulas and just algebra in general. That's why I love this chapter. I mean, I love every chapter. What am I talking about? All right, so if you've labeled everything like I do, then you just plug in. So we have M2, which is 0.4 molar, times my V2, which is 100 milliliters, over my M1, which is 2 molar. So my molarities cancel, and I'm left with milliliters. That's why it's okay to have milliliters or liters in this type of problem. If I'd given you liters, your answer would just be in liters. Since I gave you milliliters, your answer is just in milliliters. All right, so I multiply the top 2 numbers and divide by the bottom, and so once I do that, I got 20 And then my unit is milliliters because, of course, that's the unit that was given in the problem. All right, so hopefully the dilution is not as bad. A lot of people have more trouble with that molarity formula because of the whole grams and moles thing. In dilution, we can't really have that issue. There's just my work. All right, so let's look at another one. So it says how many milliliters, so again, I'm looking for V1, of a solution of 4 molar Ki, or potassium iodide, so there's my M1, are needed to prepare, so see, this is what we're preparing, 250 milliliters, that's my V2, of 0.76 molar Ki, so that's my M2. Another thing is if you're getting confused about your M1 and V1, in a dilution, you are reducing the molarity. So your M1 always has to be larger than your M2. That's another way to look at it. All right, so again, I need to rearrange my formula. So I have M1V1 equals M2V2. So my V1 needs to be alone because, of course, it has to be by itself since I'm solving for it. So I divide both sides by M1. So V1 is M2V2 divided by M1. And so again, since I've already gotten everything all labeled at the top, I just plug in. So my M2 is 0.76 molar. My V2 is 250 milliliters, because remember milliliters is fine for this formula. And my M1 is 4 molar. So my molarities cancel and I'm left with milliliters. So I multiply my top two numbers and divide by that 4 on bottom. And I ended up getting 47.5 milliliters. Alright, so hopefully this is making a lot of sense. We're just plugging in and rearranging in formulas. Plug and chug is one of my college professors used to call it. Alright, so I want you to pause it and try number 2 real quick. And then I'll assume you've done that, and we'll look at it together. Now, once you see me start working it out, you may look at what you did and assume you got it wrong right at the very beginning. But I want you to just hang on a second, don't erase anything, just watch what I do, and most likely, even though we may have done it a different way, we will get the same answer if you did it the wrong way that I'm thinking you did. Now, you can do it another wrong way and just get the wrong answer. All right, so it says, how could you prepare? What did I tell you about what you're preparing? Those are the 2s. A lot of you saw 250 milliliters and you probably labeled it as V1, which, remember, don't go back and change anything yet. Just leave it and just watch what I do, okay? So it says, how could you prepare? So I know that means this is my second volume. 250 milliliters is the volume 2 because it's asking, how can I prepare this? Of 0.2 molar NaCl, so this is my M2. So even though they're listed first in the question, they're still my second ones. Using only a solution of 1 molar NaCl and water. So this is my M1. So I have a V2, I have an M2, I have an M1. I am looking for V1. Now some of y'all, you probably saw for V2. You probably called this V1, M1, and M2. If you did that, you're gonna get the same answer. Like, it just works out that way. That's why I said don't go back. But I'm just saying, for future purposes, remember what you're preparing, those are the 2 values. All right, so I start with my formula, M1V1 equals M2V2. I'm solving for V1 again. Remember, that's just an pattern that I didn't really mean to happen. You don't always solve for V1, but you know, I get those patterns sometimes. So I divide both sides by M1. So V1 equals M2 times V2 divided by M1. And so now I'm ready to plug in. So I have 0.2 molar for my M2. I have 250 milliliters for my V2. And I have 1 molar for my M1. So my molarities cancel, and so I just do 0.2 times 250 because, of course, dividing by 1 doesn't change the answer name. And I get 50 milliliters. Okay? So what is these numbers that we're calculating, what does it actually mean? Because if you notice, this question says, how could you prepare? What that means is, if I want to make a 0.2 concentrated, like molar concentration solution, and I want 250 milliliters of it, what I need to do is take 50 milliliters of the original solution and then add enough water to get it to 250 milliliters. So in other words, I would take a beaker or a volumetric flask or Erlenmeyer flask, depending on how precise I want it to be. I would add 50 milliliters of this NaCl solution, and then I would add 200 milliliters of water, and that would change the concentration to 0.2 molar. That's all that these calculations need. All right, so we're gonna stop here for our first lesson video. Like I said, the only reason I'm splitting it into two is just because of the excessive amount of examples that I give you for all of this. But hopefully you're not finding it too difficult.